Hello everyone, hope you all are doing well. So in this video, we'll discuss the third problem of Leetcode Weekly Contest 336. It's a medium level problem, but having accuracy on the lower side, relatively better than the other third level problems that you get. But yeah, once we discuss the solution, you'll see that it's sort of a trivial problem, but we just need to find it out that it's a trivial problem, right? So the problem name is count the number of beautiful subarrays. So you are given a zero index integer array nums. In one operation, you can choose two different indices I and j such that I and j obviously are valid indices, so lying between 0 to nums.length, and choose a non-negative integer k such that the kth bit in the binary representation of nums of I and nums of j is 1. Okay, subtract 2 raised to k from nums of I and nums of j. So a subarray is beautiful if it is possible to make all of its element equals to 0 after applying the above operation any number of times. Now return the number of beautiful subarrays in the nums in the array nums. A subarray is contiguous non-empty sequence of elements within an array, right? So what it is trying to say, it says that what you need to do, you have an array, okay? You have an array, choose two indices, suppose this and this, I and j, okay? Now what you will do, at any particular point of time within this subarray, pick any two elements which you want, and if the kth bit, now k can be anything, right? If the kth bit is set in both the numbers that you have picked, okay, then basically unset it, or I can say subtract 2 raised to k from it, okay, right? You do that. Now after that, obviously you get two new numbers. So you keep on doing this for all the elements of this subarray. That means at every particular given point of time, you pick two elements from the subarray and perform this operation, okay, till you get a pair that, okay, the kth bit in two numbers is set, so you unset them, okay. You keep on doing this, and if finally every element in this subarray is 0, then this subarray is known as a beautiful subarray, and we need to return the number of beautiful subarrays in this array. Simple, right? So now, for example, if this is my array, okay, this is my array. So just see, suppose I pick 312, okay, I pick 312, so 312. Now the binary representation of this one is 1 1, this is 0 1, this is 1 0. So let's pick any two numbers. So suppose this bit, I consider this bit, so this bit is set here and here, okay. So if you subtract 2 raised to, what do you call it, kth bit, so this is the first bit, right? So I need to subtract the 0, k equals to 0, right? K equals to 0, so I need to subtract this bit. So if I subtract 1 from both of them, what do I get? I get 1 0 here, I get 0 0 here, and this remains to be 1 0. Now what you will do, you will pick this and this and remove this bit. And when you remove this bit, what you get? 0 0 0 0 0 0. So here you see that all the elements have become 0 after performing two operations, okay, and hence this is a beautiful subarray. Acha, what about the other subarray? So suppose I pick 4 3 1 2 4. So what happens? This 3 we have already seen how they become 0. Now if I talk about 4, so this is 1 0 0, this is 1 0 0. Pick these two numbers, unset these two, you get 0 0. So everything becomes 0. So this is the other subarray that you can get, okay. So total, you can check for the other possibilities, but these are the only two subarrays that are beautiful for this, okay. So you have two, two is your answer, that there are two beautiful subarrays, okay. If I talk about 1 10 and 4, so this one is 0 1, okay, this one is 8 this. So just see whether you can do something or not. So here the first bit is 1. Now you see there is no other number having the first bit as 1. So obviously this guy cannot form a pair, and hence this number will never become 0. So obviously this, right? So that means you cannot have a beautiful subarray which includes this element, okay. Now let's come to these two, okay. Again, this element is 1 here, but you do not have any other element that is 1 here. So obviously there is no subarray that can be formed which is a beautiful subarray, right? So yeah, that's it. So total number of subarrays are 0, okay. So now again, how to approach this problem? What's the observation here? So the first thing is, just see what it is saying. Choose a non-negative integer k such that the kth bit in the binary representation of this and this is 1, okay, and you unset it, okay, you unset it. So just see one thing. If this is my subarray, sorry, if this is my array, okay, and this subarray is beautiful, then what, how can I say, what is the other property of this subarray? That every element is 0. Every element is 0. And how it became 0? It became 0 because I picked up any two numbers and I removed a particular set bit from both of them, right? So from both of them. So what's the property of XOR? What is the property of XOR? XOR says that if a particular bit, okay, if I take XOR of two numbers, like for example I take XOR of 1 1, and that means 3 and 1, okay, so you take bitwise XOR, okay, bitwise XOR. So the first bit is 1 1. So when you have the same bits, okay, when you have the same bits, or when you have even occurrences of a particular bit, okay, so what happens? 1 and 1 1 will give you 0, and here you have 1 and 0, so this will give you 1, right? This is how you take XOR, right? So for two numbers, if a particular bit in both the numbers is same, you get 0, and if they are different, you get 1, okay. Now what happens here is you are picking a particular bit. You are picking a particular bit, like for example this bit from a number and this bit from a number, and subtracting it, okay. So if this is my beautiful subarray, okay, if this is my beautiful subarray, then what I can do, if I take XOR of this part, okay, if I take XOR of this part, what will happen? The XOR should come out to be 0. Why it will come out to be 0? Because at every step you are picking up two numbers, and in those two numbers you pick up the kth bit, right? If they are set. If they are unset, you are already good to go, but you are picking the kth bit from here and here. So what will happen? These will cancel in pairs. These will cancel in pairs. Like for example 1 0 1 0, suppose 1 1 1 0. So if you pick this, these will be removed. These will be removed. So if you take a XOR of this one, this guy will be removed, right? So taking a XOR of a beautiful subarray gives you 0, because every kth bit will cancel out each other, okay, will cancel out each other. Then only you will be able to get the resultant as XOR, or every element as 0. Simple. That's what you will do, okay. So this problem is exactly similar to finding that part where you see that, okay, how many subarrays have a sum equals to 0. So what do you do? If this is your subarray, if this is your array, sorry, and suppose this array has a sum of 0, the sum of this subarray is 0. So what do you do? Suppose till here you got a sum of s, and here also you got a sum of s. That means the sum of these elements was 0, right? Then only the sum here and here is same. What about these elements? These elements added up to give you 0 only, right? So similar to this, if the XOR till here was x and XOR till here is also x, okay, that means XOR of these elements is 0, because x XOR 0 will give you x. Simple. Okay, so the first thing is why XOR is giving us the answer. XOR is giving us the answer because at every particular point of time you are picking up two numbers, okay, you are picking up two numbers and picking up a particular bit of those two numbers, right? And they are cancelling out each other. So if you take XOR, obviously they will be removed, right? They will be nullified, okay. Like for example, in case of 3 2 1, what happened? This was 1 1, this was 1 0 1 1, sorry, 0 1. So here if you take this, how many ones are here? 2. How many ones are here? 2. Okay, so if you take XOR, if you suppose you add 1 1 and 1 1 again, so what happens? Suppose you have 3 2 1 3 3, what happens? Total number of ones here is 4, total number of ones here is 4. So that means you have even number of ones at every bit position. So they will cancel out each other in pairs, and finally you will be getting 0. So I'll be using the exact same solution that you write for those cases. Your answer equals to 0. I take a map to keep a track of that. Okay, if this is my array, so till here what is the XOR? Okay, and if I come at this particular position, suppose the XOR till here is x, so I check that how many prefix arrays, how many prefix subarrays have a XOR equals to x. Okay, have a XOR equals to z. Suppose here also I had x, okay, here also I had x, and here also I had x. So the prefix XOR of this part was x and of this part was x. So how many subarrays do I have? Beautiful subarrays. One subarray will be this and the other subarray will be this, right? So similar. So that is why I have taken a hash map, and obviously you put 0 1. Okay, you start with 1, right? You start with 1. That initially your XOR is 0, so you start with 1, and then you take XOR with the current number, take the current count. If your map contains XOR, so current count equals to this, you increment your answer with this count and you update your map. Simple. And finally you return your answer. Okay. So yeah, if you are familiar with how to take out what do you call it, the prefix sum to calculate the number of subarrays having sum equals to 0, then this should not be too tough to understand, right? So yeah, I have explained you briefly. The main intention of this explanation was that you see that how you convert this guy into a prefix or solution. Okay, prefix or solution. Okay, that was the main intention. So yeah, I hope you learned something new from this video. Do let me know in case of any queries. Mention that in the comments. I'll revert on each one of them. Thank you. Take care. Bye bye.